Hi, and welcome to this quick guide on using Safran Risk. Safran Risk has been designed from the ground up to be a quantitative schedule risk tool. When you open the product, the first tab you'll see is the Global Risk tab. The Global Risk tab is a brilliant place to store risks that you may want to use between projects. But before we start, we need to open a schedule. Clicking on the Schedule tab reveals a scheduling environment. You have full access to be able to create new schedules, import schedules from Primavera via XER format or Microsoft Project, or open projects from the native database. I'm going to open the sample project that ships with the product, the drone prototype. Once the project's open, you'll see a familiar environment where you can see critical path, WBS structure, durations. By clicking on the view here, you'll be able to change the view slightly to look at activity data, relationships between activities, resources, and a whole host of other things you'd expect to find in a planning environment. By changing the outline view here, we can move between a group view or an outline view. We can restructure the project by WBS or by any activity code. This is important because it affects how we see the project throughout the rest of the tool. Once the project's opened, you'll see a number of tabs appear across the top. This is effectively the process that you'll walk through to do a traditional risk analysis. The tabs towards the left of the green Analyze tab represent the inputs to the model, and the tabs to the right are the outputs. Let's take a walk through the steps from left to right. Once we've opened our schedule, the next thing we would do is look at the schedule warnings. Schedule warnings help us check that the project is suitable for running a risk analysis. We're looking for a network that is free-flowing, something that does not have constraints or open ends. You can see the checks that are performed by clicking on the Options button here. And if you don't want to include a particular test, you can exclude it here. This particular example shows that we have 4 warnings, 2 of which we've already accepted, being the start of the project, which is an open end, and the finish of the project. In this case, the P contract activity has a lag that exceeds my specified percentage. I can go and review the activity simply by clicking on the link here. It takes me straight to the activity so I can review it. I'm going to ignore these changes going forward because even though they're warnings, they don't actually stop me performing an analysis. The next tab is the Project Risk tab. This is the one place where we define all of the quantitative risks in our project. Risks can include things like risk events, risk factors, or just basic uncertainty. Each risk is given a probability, an associated colour, and here you can define the impact. Let's look at this one in more detail. The first thing that we can see is that it has a probability of 40%. This means that really it's a type of event. It's something that's going to fire only 40% of the time, and it will have some kind of impact. The impact here has been defined as schedule only. The impact is relative to any activities that it's assigned to, and what it's saying here is that its impact may be between 100% and 250% of the original base estimate. Let's have a look at another risk. This one, design specification change, has a probability of 100%. This means it's behaving more like a factor. It's going to exist on every iteration of the Monte Carlo analysis. In this case, we've defined 2 types of impact, a schedule and a cost, both of which are relative and have percentages that vary by 80% to 150% for time and 70% to 195% for cost. Other distribution types are available. So here, if we look at external communications, for example, we're looking at a cumulative distribution. We also support uniform, normal, and discrete distribution types. Additionally, some risks may impact rather than relatively with an absolute value. Absolute values means that in this case, when there's a change to the legal governance, 20% of the time we expect these activities to increase by 80 days to 150 days. And finally, we have one more type of risk, an uncertainty risk. Here we've defined high estimate uncertainty with 100% probability of creating a relative uncertainty. Here we're using the trigen distribution. Let me just extend this a little bit so you can see, where we're specifying the low and the max ranges with our upper and lower tolerance levels. The important thing to notice here is that we're saying that this risk impacts each task or activity independently, unlike a factor which will impact each risk with the same value on each iteration. And here you can see the rest of the quantitative uncertainties that we have defined for our model. The next tab is the correlation tab. This allows me to correlate any risk with any other risk. This is done using an impact matrix. Each risk is listed across the top and down the left, with the blue areas here representing the match between itself. Obviously you can't enter numbers in these cells. For example, let's say I want to create some correlation between the merger and acquisition schedule impact and procurement delays. I can click on the cell here and add a correlation. Let's add a correlation of 80%. You'll notice as I add the risk, or add the correlation, the corresponding value is entered here. It doesn't matter which way around I enter this data. Alternatively, I may also want to add a correlation between the merger and acquisition probability of this risk occurring and outsourcing. In this case, I'm going to add a negative correlation, a high number of minus 90%, which basically says if we go through a merger and acquisition, it's very unlikely that we would actually go through the outsourcing exercise as well. We can simplify this view to make it easier to read by simply clicking on the hide empty cells. Now we're only looking at the minimal amount of data that we need to show the correlation that we have. It's worth noting that if you're just using risk factors and you don't have correlation between the factors in your models, you may not even need to use the correlation tab at all. Unlike other systems that use duration 3-point estimates, where correlation can become very complicated, that's not the case with Safran risk. Once we've defined our risks, the next thing to do is to map those to the activities in the project. Using the risk mapping tab, you'll see down the left here are the activities that we defined in our schedule, organized as they are on the schedule. If I pop back to the schedule tab for a second and change the group view, so we're reorganizing the project structure and back to mappings, you'll see that this has also been reorganized to reflect the schedule in the schedule tab. That's a very powerful feature, as it allows you to reorganize your schedule at any time. If you want to create inputs via activity codes or project codes, it's very simple to do that and take a different view of your project. Back in the risk mapping tab, you'll see the activities listed down the left and the risks listed across the top. It's simply a question of mapping each activity to each risk, and I do that by simply clicking on the tick here. It's worth noting that we can also assign risks to summaries, even though the summaries technically may not exist. For example, low uncertainty can here be applied to the construction phase, and you notice as I tick it, all of the subordinate activities take on that checkbox. If I untick one, you'll notice that the summary shows me a square showing that not all subtasks are affected, and I can also unassign from this point as well. On any row that I click on, I will see the assigned risks, so that's all of the checkboxes across the row listed here on the right hand side. So this is a very convenient way to look and see on any activity which individual risks have been assigned. The next step is to analyze the risks. Clicking on the Analyze tab reveals the number of iterations that I need to run. In this case we're going to run 1,000, the ability to set the seed, and I can optionally choose to include or exclude my correlations that I set in the correlation tab to see the difference. You'll also notice on the left hand side here all the risks that we've assumed in the model. You can exclude a risk to perform a sensitivity analysis at any time, but we'll come back to that later. Let's run the risks as they stand for now. And you'll notice that the first view that we see after that is the traditional histogram view. Down the left hand side here you have the project structure, so you can click on any you can drill down to any activity. This structure also reflects the structure that we saw in the schedule tab. Let's go back to the entire project for a second, and as usual you can read off, for example, the deterministic finish and see that this has a probability of 1%, that's listed here, and we can also drill back down from a selected percentage, in this case 90%, to see what the deterministic, we'll see what the risk date is. In this case it's the 11th of October. If you don't want to use 90%, you can change that in here. I'll just change this to 80% because that's what I need to use for this particular analysis, and once I've done that you'll see the line has moved. So this is all very good traditional stuff. Down the bottom here you'll see I also have a cost histogram and also duration. So this is duration for the entire project, but you have duration for the various activities within the model too. The next tab is the drivers tab. This is traditionally a tornado graph showing the inputs that are most sensitive to the model. In this case, because we have treated all the risks separately, we have two tornadoes. The one on the left shows the sensitivity to each risk, and the one on the right is the activities which are most sensitive. It's clear in this tornado that e-communication is the biggest risk, and it has a correlation of 61%, which we can see with the 0.61 in the tooltip there. One of the shortfalls of this type of graph is that although it's useful to see which are the biggest risks or which activities in the model are the most sensitive, it doesn't actually help me find out what is the impact in terms of days and dollars, and for that we use our sensitivity analysis report. The sensitivity analysis is started by clicking on the Calculate Impacts button. This will rerun the analysis a number of times, excluding each risk in turn. This results in a number of S-curves that you can see here. It's probably clearer to see what's going on by removing all of the curves except for two. In this case, we're leaving in place the curve that says none and the curve that says e-communications. None is the same curve as we had in the normal distribution graph here, and that means none of the risks have been removed. You'll see that the difference between this and all the risks is 0, whereas in e-communication, which is the green curve, results in this curve here. The numbers of minus 260 and minus 17,000 are calculated by reading across at a specific confidence level, in this case 80%, and the difference is shown down here. So this is the difference between these 2 days. What that tells us is that by entirely mitigating e-communication as a risk, we could save ourselves 260 days and bring the project in earlier. It brings about an important point when considering what the schedule and cost impact of each risk is. You must be able to determine the level of confidence that you want to work at. If we change the level of confidence here using the slider, you'll see the line across here is moved, and that results in a different set of values here. You can also sort the graph by cost impact or schedule impact to see which risks are the most important. The sensitivity analysis in Safran Risk is very powerful. By automatically calculating the impact of each risk, we can save you a lot of time. However, sometimes you might need a little bit more control and want to do things manually. I'm going to show you now how you can very quickly calculate on your own the impact of e-communication, but we're going to take things a stage further and imagine what would happen if we wanted to understand the impact of fully mitigating e-communication and ash cloud. You'll notice that ash cloud at the moment has a value of 142 days saved. We can't simply add up these numbers, so let's have a look at how we would do that. First of all, we go back to the Analyze tab to remind ourselves this is what happens when all of the risks are included. If I look at the distribution graph for the entire project, I would get this curve. I click on this Send to Comparison chart, and that will generate a curve as follows. I'm going to relabel this as none to follow the same pattern that we did in the sensitivity analysis. Going back to the Analyze chart now, I can remove e-communication and then reanalyze. That produces a slightly different curve, but it's very difficult here to see what the difference is. By clicking send to comparison, I'm able to send that curve in here as well, and I'm going to label this e-communication in the same format that we did before. And here we can see, unsurprisingly, the difference is 260 days, exactly as we did with the sensitivity analysis. We'll take things one stage further now, and we'll also remove ash cloud out of this analysis. So now I have removed ash cloud and e-communication. By running the analysis one more time, I'm able to export this curve again, and now I see that potentially, if I could mitigate both of those risks, I could save up to 386 days. That's a different number to the 260 plus 142 days that we would have had before. Obviously, it's slightly less because this scenario is different in that it includes two mitigated risks, not one on its own. Hopefully, you can see that this type of approach is very powerful. You can create any number of alternative scenarios and calculate the difference using the chart here. The final report I want to show you is the critical path map. We'll quickly jump back to the beginning and just switch on our two missing risks and reanalyze. The critical path map helps me understand the number of critical paths that were generated during the analysis. On the left hand side, I can see each unique path that's been identified and its associated frequency. So here I can see that there were 10 unique paths identified, and if I click on frequency, I can see that path 1 was the most frequently occurring. I can see what path 1 looks like by simply ticking it here and visualizing it. I see a few things here. On the right hand side, you'll see the S-curve. Each dot represents where this particular path finished on that S-curve. It's more obvious if you choose a different path, say for example path 5 or maybe path 6 in this case. This shows me when the project finished early generally. By clicking on a path and listing the activities, I can see which activities are being used in the schedule, and I can also see the criticality of each individual activity. So in this example, path 1 occurs 48% of the time, and the fabricate engine subframe is an activity that's 53% critical. So that must also occur in some other paths. And here on the side here, I can see that the activity fabricate engine subframe also occurs in path 1, path 10, path 5, path 6, and path 9. So by switching on various paths, I'm able to build up a picture of what each path looks like and help gain some more insight as to what's actually happening in the network. It's a new report, and it's a very powerful way of looking at what is quite a composite problem. So I hope you found that useful. If you'd like to find out more, please contact Safran at www.safran.com. Thanks very much. Bye.